Hi there. This is a talk about the new features in MySQL 8. My name is Dave Stokes. I'm a MySQL community manager. I've been on the community team for 11 years. And I must say, I'm sorry I'm not in Ohio this year. Oracle does not allow me to travel. But hopefully next year we'll all be face-to-face again. And let me proceed. I started using MySQL when it first became available. I've used it in many projects. I've been an open source advocate and user for a long time, usually because I was working at places where we couldn't afford the big buck stuff. I joined MySQL AB many years ago as a PHP programmer on the certification team, eventually became the certification manager. Joined the community team 11 years ago. Like I said, I have most of the MySQL certifications out there, including the 8.0 Dev and DBA. I live in Texas and have the required hound dog and pickup truck. And by the way, the slides for this talk are at slideshow.net/Dave Stokes. And if you need to get a hold of me, I'm at Stoker on Twitter, or there's my email. So MySQL is 25 years old, which means we've been around a very, very long time in the software business. And we're still adding new features and still growing. And let me first say, if you're using MySQL 5.6, it was end of life almost a year ago. So please upgrade to MySQL 5.7 or better yet 8.0. Now MySQL 8.0 was made generally available in April 2018. For those of you who are waiting us to work out the initial glitches, they're long gone. And I want to let you know that we also release every 3 months or so. We also are on the CI/CD bandwagon like most of you. By the way, if you haven't looked at our software for a while, it is much more complex than it was back in the 5.5 era. Oracle has put a whole bunch of engineering rigor on our product, and by releasing every few months, we get better products to the customers quicker. We used to wait a long time before we got new versions out to you. By the way, same release number on all our products. That's the server, the clients, the connectors, the routers, the utilities, and by the way, they're tested together and made sure that they integrate together. So no more wondering which version to run. Our latest is all 8.0.2.7. So if you're going to run a cluster, shell, workbench, router, or connectors or whatever, you want the same version, and the latest and greatest is 8.0.2.7. So the first thing is when I start talking about MySQL 8.0, mainly to folks who are running older versions, what has changed? Well, a whole lot. We basically pulled out all the guts and redid it. The first big change was the data dictionary. In the past, if you've gone under var lib MySQL, you've seen a whole bunch of .frms, MYIs, MYDs. That was your metadata. And besides taking up inodes and being the target of judicious junior DB system admins who weren't quite sure what they were doing, those files tended to attract attention that they didn't need and get deleted accidentally. So that is all now kept in the database inside an InnoDB table. InnoDB is our most popular storage engine. It knows how to do point-in-time recovery, so if something does go wrong with your service, like the power gets cut, it knows how to recover to a certain point of time and keep everything together. And by the way, since this is using less inodes, there's a lot less mess. And the side effect of this is that there is good news. Since it's not showing up inodes, you can now have millions of tables in a schema. By the way, there's bad news to this in that you can now have millions of tables in a schema. I think most people give up around 23, 25 million tables. If you want to do it, you can do that. I know sometime that someone will be bitten in the butt by this, but so far, no. By the way, we re-optimized everything for UTF-8 MB4. Well, why is that? Well, we needed to have Unicode support because we have users all over the world. The old days of just being able to use Latin 1 with the sweetest collation are long gone. Yes, this is 4 bytes instead of like Latin 1 byte, but we've worked on it to make it more efficient. This also gives you support for the Chinese, Japanese, and Korean character sets, which are becoming more important every year. And also the big thing that everyone wants in their database are emojis. So you now have that with MySQL 8.0. Also, we added hash joins. If you're doing a equality query. It doesn't have to always be an equality, but where you're comparing two values, like this one's table1.column1, table2.column1, and we have a less than sign here. We'll now do a hash join. Before, everything else was a nested loop where we would read through one table and then loop off to the other table. Well, the hash joins, you throw them all in memory and your data comes back much faster. This is very impressive performance that you don't have to turn it, it's just there by default. And here's some performance examples. In blue, you see our hash join, and in orange, you see our nested loop. And you can see in a lot of cases down here, you can barely see the little blue line. So some of your queries are going to run a lot faster. Also, MySQL can be used as a NoSQL JSON document store. So JSON's become the interchange format of choice, and we decided to come up with a new protocol. And the protocol is based on Google Protobufs, which cuts down on a lot of possibilities for SQL injection. By the way, this is not an ORM, it's its own protocol. It works with our JSON document store, it works with our relational tables. The API, you'll find, is very modern and follows best design practices, so you don't have to fight SQL syntax unless you want to. And you get the ability to use SQL or our new API. It's your choice. We're trying to give you the most flexibility possible. Also, we have a new shell. It's an advanced client and code editor. It has command completion, extensive support. It actually speaks 3 dialects. SQL, as you expect, because we are a relational database and you need structured query language. Also, you can use libraries and write scripts in Python or JavaScript and call them later. Very handy tool that. It's also our admin tool for InnoDB Cluster and Replica Set replication. So if you need a high availability cluster or you're using traditional MySQL replication but don't want to have to do a lot of the setup, and I'll go into a little bit of that more later, it's there. It also has a 5.7 to 8.0 upgrade checker to make sure that you're not using new reserved words and that you're aware of some of the changes going to go on. It has a very fast bulk loader, so if you're importing comma separated, tab separated, or JSON data, it will do it in parallel with multiple threads. Also, we have utilities that I think will impress you for dumping schemas, just one schema or one database, or the entire instance and the restoration. Very, very fast. So if you're using MySQL dump, you might want to look into these. Much faster, much easier, much more robust. Well, our new shell, hopefully you can see this well, is no longer monochromatic. You authenticate in and it tells you what mode you're in, JS for JavaScript, PY for Python, and SQL for SQL. Now, if you run a status report on this, I want to point out that it tells you that by default we are using TLS 1.3 because it's easier to keep the bad stuff out by default. If you don't need it, you can turn it off, but if you do need it, it's there. This also tells you that we're talking to port 33060 instead of our traditional 3306. That's because we're using the X protocol, which you can see the protocol version here. You notice that all the client and server communication character sets are in UTF-8MB4. In this case, compression is disabled because we're not sending data back and forth. Something else we added with 8.0 was invisible indexes. In the past, if you had an index you weren't quite sure was useful, you might delete it. And suddenly everyone in the world is depending on that index. You didn't need it, but everyone else did. And then you have to go back and rebuild it, which can take seconds, minutes, hours, possibly longer. Well, what you can do now is alter the index using an alter table statement and make it invisible. That means the optimizer for the entire server can't see that index. And if that index isn't needed and no one complains for a while, don't delete it right away. Just make sure, because it might be something that runs once a quarter or half a year. Mark it as a candidate to be removed because indexes do take up space and there is maintenance and all that other stuff. But if you need to make that index invisible again, you just do another alter index and make it visible. Also, we've added invisible columns. Well, why is this, Dave? Well, imagine you have an old application where the queries are badly written and they do select star from customers, and you want to add a primary key to a table. Well, you just can't add an extra column to the database, because when you do the select star, all that's going to be reported and your code would have to be modified to accept that new column. Well, if you mark a new column as invisible, it doesn't happen unless you directly query it. So if you want to add a new column called foo and you want to see everything in the table, you'd have to do select star comma foo to explicitly get that. Here's a quick example. Here we're going to create a table and we're going to call it not here. Have a column called ID, that's our primary key. Have a column called A, that's an integer, B, that's an integer, but it's invisible. So we insert some data into the table, and if we do a select star from not here, we get ID and A, no B. To get B, we have to explicitly say comma B. We also notice here I could have put in select ID comma A comma B. New asynchronous connections failover for those folks using replication. We've done a lot of work with this and doing stuff in parallel. Things work in parallel by default right now. One of the neat things over is that if you have a lot of sources going to replicas and suddenly a new source needs to be used because the old source is failing or going offline, you can have a list of possible donor sources and that will take care of it. Now, this helps keep everything synchronized with multiple servers or groups of servers that share data. Now, the list of potential sources is saved on the replica, not on the primary. So in case something goes wrong, the replica knows where to go ask to get its replication data from. And you can also weight this for your priority. And this supports our group replication. Something else I found very handy is in the past as a DBA, someone will come up and say, hey, I'm Bill from accounting and I can't get into this table. And you go out there and look in your MySQL.user table and there's 5 Bills, 2 Billies and a William. So it's kind of hard to know which one is which. And you'd also end up with a lot of security exposure and it gets messy and you tend to upset folks. So what we can do now is we can, when we create a user, we can put in a comment there and say, hey, this is Bill Johnson. He's in room 114, extension 1234. Or you run an alter user. In this case, we're saying this user has her email there. And if you look into the MySQL user table, you'll actually see how this is annotated in there in a JSON document. Also, something we've added is the ability to turn off redo logging for loading data. Pretend that you have a new replica coming up in your replication data, and it is feeding another server or two, and it has all the nice stuff enabled. But when you're trying to put in data, you also don't need to write a copy of that data out there. So what you can do is turn off the redo log, which means as the data is loaded, it's not preparing to go back and restore it because you're restoring it for the first time. The shell backup utilities I mentioned earlier are very nice. They work in parallel, multiple threads, do file compression. In this example here, util.dump instance, the file where I'm going to put it, I put in here and do a show progress. You can't really see the progress bar on this, unfortunately. I should do a video of that. And it tells you how many schemas are dumped, tables, the compressed size, the uncompressed size, the number of rows written, and the throughput. There's also a way just to do a particular schema, and the corresponding restore utility also works in parallel. Something we do that's rather neat is as we're doing transactions for replication, that stuff is written to a file that's compressed. And when we send it to the replicas, it stays compressed, and the replicas can read it in an uncompressed state. There's no writing it, compressing it, sending it over, uncompressing, and then reading it. It's much faster, much easier, takes up less time and network space. Also, we can generate random passwords for you. For a long time in MySQL, you've been able to determine the complexity of your passwords, length, number of uppercase, number of lowercase, number of special characters, how often it has to be changed, number of times you have to wait before reusing a password, that sort of thing. But there is really no easy way for folks to get a random password. Well, now the server will generate for you and store it in hash. So what is stored is the hash version of this. And if you want to see more, here's a little blog I wrote on that. Also, we added explain analyze. For those who debugging queries, trying to get better performance out of them, explain works by running your query or looking at your query and determining the optimum way to run it. Now, in the past, explain has always used the historical information, kind of like a GPS. And like a GPS, if you have old information, things can go bad. Like when I go to lunch, left out of the driveway, right at the stop sign, over the railroad tracks, and there's the restaurant on the right. Well, may not know this morning when I go to get out of the driveway is that my neighbor has washed out the road, there's a train parked over the railroad tracks, and the restaurant's moved to the other side of the street. So historical information is great, but it's not perfect. With explain analyze, we can actually go out and run the query and get the actual time. By the way, if you're running explain and explain analyze and see a skew between the numbers, it's time to run analyze table on your tables. MultiValue indexes. We don't have a array data type, so a lot of people started using our JSON data type for arrays. The only trouble with that is our indexing software was stuck where you had one row equals one entry in the index. Doesn't work for arrays. So with multi-value indexes, we can actually index every item in that array, so you have multiple index entries per row. JSON document validation. This is from the wonderful folks at jasonschema.org. They're working on getting this as an RFC. The idea is JSON's free format. You can't really, everything's free flow. If I want to store the data for an email as email and you want to do it camel case and someone else wants to spell electronic mail, or someone just calls it mail, that's okay. But when you're trying to search for someone's email address and you have those various keys out there, it gets really messy. So what the JSON schema folks did and what our engineers instituted was a way to check the schema of the data coming in versus what you want. Now, in this example, we're going to use the JSON schema valid function, where we're going to say we're expecting an object, and the properties of the object is that the key is called my age. The data will be a number. If it's not a number, reject it. The minimum value is 28. The maximum value is 99. So if it's under 28 or over 99, it'll be rejected. And by the way, it's required. You actually want to know their age. For some reason, you really need that in there, and you want to make sure that it's there. Now, it's easier to keep the bad data out than go back and fix it. So when we create this table here, we're going to have a column of type JSON, and we're going to set up this constraint check that you've seen here using the JSON schema valid function. And if we go to input data that doesn't fit, here, the first example here, my age 27, constraint check, my age in range is violated. It's not going to let you put in the bad data. For those of you who should know that you always check everything that the users give you before you put it in the database. This is another way to reassure that you're there. Meanwhile, if we go to insert a record where everything's valid, it goes swimmingly. By the way, nice little blog on that if you want to go into that. By the way, you don't have to run MySQL Upgrade. It now runs automatically. We have enough versioning information stored in the data dictionary to be able to tell. In the past, you'd see stuff on the internet where someone said, hey, I just upgraded MySQL and I'm getting complaints about this column's missing or this is acting weirdly. We were changing metadata, but we needed MySQL Upgrade to go out and update some of the versions of that. Well, it runs automatically, so you don't have to worry about that anymore. One of the other things you saw is a constraint check. What they do is they let you check your data that it has certain values that you want before you put it in. In this example, we're creating a table called T1. We're going to check to see that C1 is not equal to C2. And C2 down here is a column. C1 here is another column. Also, we're going to check to make sure that C1 is greater than 10. We're also going to have a constraint, and notice here that we're naming the constraint C2 positive. Well, why do you recommend that, Dave? Well, if something fails, it's going to come back here on this one and say constraint check 2 or constraint check 1 failed. Doesn't really tell you anything. If something fails here, it says constraint C2 positive failed, and you look at your data and said, ah, I had a minus in front of that. Also, we now have histograms. These are a way to look at your data to tell the optimizer how it's laid out. The optimizer assumes that your data has an even distribution all the way along through the column. So when it's making a prediction on how it wants to run your query, trying to optimize it, it assumes that everything's even, and if it's not, the prediction is wrong. And it's like going to a contractor and saying, hey, could you do this for me? And say, yeah, I can do that for $5. It ends up being $50. You can get upset. Same thing with the optimizer. It makes a bad guess, and the query plan goes bad. Now, the great thing about histograms is that if your data isn't churning, you only have to do it once or rerun it as your data changes. The bad news is that they're not as up to date as, say, index, but the good news is indexes have a lot of maintenance and overhead. So this gets rid of that overhead issue and the cost there. So if you have data that doesn't churn, but you still want to be able to search through it quickly, consider using a histogram. Also, we added cats. No, I'm not talking the musical/movie. Some folks at, I believe, the University of Michigan came up with the idea of contention-aware transaction scheduling. What happens is you have a hot row, hot column in your data, and every query is coming in, is hammering and saying, I want that data, and I want to lock it. Well, the basic idea here, and I'm boiling down an academic paper, which is a bad thing to do. The idea is this is a way of how to get rid of the contention or reduce the contention. When the load hits a certain percentage, it switches on, and it handles the hot queries faster with higher priority than anyone else. Now, previously we had a first in, first out, so someone coming in and locking something that's kind of a low priority and they're just kind of gazing through stuff, everyone else has to block behind them. Or if you're trying to do transactions on that data, you want to get that in and out as fast as possible. By the way, we've done a lot for JSON support. One of the neat things we added was the JSON Table function. What this does is it takes your unstructured JSON data and temporarily turns it into a structured table for processing with SQL commands. In this example, we're going to take a JSON column called doc. We're going to read the entire document, and we're going to take anything that is called name in the document. This is the here pointer for the document. We're going to cast it as a car20 and call it country name. And we're going to find anything that is called independence year, cast that to an integer, and then we can pass that on to the outer query and parse that with any SQL commands that you want. Very handy, very great. If you need to permanently have the JSON data turned into something you could parse with SQL commands, we have generated columns where you can extract part of the JSON document and put it into its own column. We added common table expressions. For those of you who've ever had trouble writing subqueries, this is manna from heaven. Great things about these, you can reference them multiple times from your query. They're very easy to read, very easy to write, very easy to understand. Some subqueries you look at and just go, oh my goodness, what are they trying to do? Now in this example, the keyword is with, and our first common table expression is we select A, B from table 1. Our second one is select CD from table 2. And then in our main query, we're selecting B and D from CTE1, and we're joining CTE2, so CTEs can be joined. Very handy, much nicer than running subqueries. We also added windowing functions. So if you're doing analytics on your data, this lets you partition your data by a column. This is great for reporting any sort of analytics. And in this example here, we're going to go out to the payments table. We're going to set up a window that we're going to call W, and we're going to get all the information. We're going to order it by date, and we want the week before this week and the current row. So if your boss wants to know how the current sales promotion is going, you can run a query like this and get the information. This gives you much more granular analysis than using a group by or some of our aggregate functions. Also, I'd like to introduce you to InnoDB Cluster. This is the way we'd like to have you start thinking about your applications. Your application is up here with a copy of MySQL Router, which is a lightweight proxy. Router has all the smarts about what's down here. Your application should not know anything down here to keep it as simple as possible. What happens is you have a request that comes into MySQL Router, and in this case we're running a read-write split. If you want to write a row of data, it's going to go to the primary. If you want to just read, the router will know which one of these machines to hand off the read request. If something happens down here, your application doesn't need to know anything about it. You might have to retry a write. So if something goes wrong during the middle of your write, check it, make sure it's gone through. If not, reissue the write. And this is all administered by our shell. Also, for those who don't need high availability and still want MySQL replication, we have something called Replica Set. The prior incantations of MySQL replication, you had to do a lot of tedious work. You know, oh, I have to point to this level of the log file to be able to read it over here. This takes care of a lot of that. It uses the clone function that I'll show you in a little bit. It has almost all the features of high availability, except that it won't do the manual switch over or failover for you. So if you're in a little more traditional environment of MySQL replication, take a look at this. Okay, clone plugin. This is really neat. You have a new box brought into production. It is set up to work on your InnoDB cluster, and the first thing it does when it gets on the cluster is said, feed me Seymour, I want information. So what happens is the new machine says, okay, I want to clone an instance, and on the remote machine it will do a copy of everything from that machine at the InnoDB table space level. It pulls it all over extremely quickly. You can do it with SSL on. It uses password protection, all that. Very, very fast, very, very neat, very, very impressive. Also, you can use MySQL without SQL. This is our JSON document store. In this example, I'm going to create a schema named FOSDEM, and after I create it, I type DB, it sees that my pointer is at FOSDEM. db.createCollection, I'm going to create a collection called A, and if I want to add a document, it's db.add and put it in a JSON document. Boom, it's there. If you're working in an environment where you don't know what your data is going to look like, but you need to start saving data and you don't have the time to go out and set up relational tables, you don't have to set up indexes or foreign keys or all that sort of stuff, this is a great way to do that. If you're used to using JSON document storage, you're going to find this very familiar. It's also a JSON document store and very quick. Also, this is something that's not part of the free community edition. Everything before this was available in the free community edition under the GPL version 2. You can go out and get binaries for just about any platform. The source code is out there as well on dev.mysql.com, and we're also on GitHub. This is our paid-for cloud infrastructure, and you might have heard some about this. This is the MySQL database service. This is the new hot product in Oracle, and basically it's Oracle engineers running your Oracle instances for you on Oracle hardware and on Oracle software. And you have 3 options at this time. First is standalone, and you get a single instance of MySQL, just like you'd have on your laptop or your server. And if you want a little bit more, you set up high availability. It sets up 3 servers for you in an InnoDB cluster. So if one of the machines has some sort of problems, it will be taken offline. If you need a new primary is needed, it will elect that, and then it will bring the secondary machine back and refeed that with data. Also, if you're doing analytics, we have HeatWave. HeatWave is designed for high-speed analytics. It is absolutely amazing. And also there's a thing called AutoTune, which is machine learning on top of that to watch your queries and the configuration and tune that for you on the fly. If you're working for a startup, please go to oracle.com/startup. We have a whole bunch of credits and marketing stuff we can work with you on. Very impressive program. Also, if you want to try that MDS, you can get $300 in credits for free for 30 days at oraclecom/cloud/free. The lower end instances, the standalone instances, the $300 will last you quite a long time. For HeatWave, it chews up a little bit faster. Please follow us on social media and connect with us. MySQL.com on Twitter, on Facebook, and on LinkedIn. By the way, if you're using the JSON data type, please buy a copy of my book. The manual is good, but this is a guide to teach you the ins and outs with lots of coding examples. Talks about the MySQL document store, talks about a lot of the really neat stuff out there that helps you use the JSON data type to its fullest. And with that, we're going to go to Q&A. Hopefully I've been able to join remotely, and I would love to hear any questions you have. And if I can't answer them, I want to thank you for listening to me today, and I hope you have a great rest of the show. And goodbye, Ohio Linux.